what goes out. Like I told you before, up to a point you have to know how much water goes in, how much sugar goes in. So you have to know how much sugar goes goes in, how much salt goes in. So every single one of that you have to actually keep track of it, because you have to make sure how much, let's say 300 grams goes in, you have to make sure that you have to get at least 300 grams of whatever sugar comes out of it. Okay, sometimes it's not in the form of your end product, maybe it is lost in the waste. You have to track everything down. Okay, so you have to make sure ada material balance and also energy balance. Kalau energy balance ni, you have to any energy, electrical energy, kinetic energy, potential energy that you've put into the system, benda yang menggerakkan this particular factory plant tu, you have to buat balance juga. Alright, so that's why you have the material and energy quantities as they pass through the food processing operation. This particular balance lah, ada material balance. Material balance ni selalu the mass lah. Okay, like sugar, protein, salt, all that goes in. This is material balance. For energy, okay, energy usually sebenarnya dia memang akan start dengan electrical energy. Electrical energy, you will change it to mechanical energy. Mechanical energy could be transformed into potential energy, kinetic energy. Ingat lagi ke semua tu? Tu semua fizik tu. Kinetic energy. Okay. So you will see a lot of this in this particular course. Okay. So material balances and energy balances are statement based on the conservation of mass and conservation of energy. Nanti I will share a video later. Okay. Alright. Ideally, like I said, usually kalau you have a very system that is actually ideal or perfect, if there is no accumulation, okay, kalau perfect lah, kalau perfect. Okay, no accumulation, what goes in must come out. Okay, ideally, okay, ni ideally lah impian setiap engineer. Ideally, but usually even kalau in batch operation pun tak semestinya benda ni jadilah. Usually there will be some losses. Okay, sebab kalau boleh, macam mana orang katakan 100% goes in, 100% should come out. Tapi like I told you before, this is not the case lah, sebab there's no system yang sempurna, tak ada perfect system. So sometimes it might be lost, sometimes akan ada build up. Tak apa, nanti I will explain to you. Okay, so operations ni is actually divided into two, which is the batch operation and also the continuous operation. Okay, so batch operation ni usually orang tak favor sangat sebab batch operation is quite costly. Okay, as compared to continuous. Continuous ni lagi cost effective. Okay. Contoh saya bagi. Let me give you an example. Let's say you guys know the process of pasteurization. Ingat lagi tak proses of
sheet kan?
Pasteurization. You want to apa orang kata ni? You nak heat the, what do you call this? You want to heat the milk. Yes, you want to heat the milk. Kejap apa saya buat ni? Saya nak insert new slide. Okay. Saya insert new slide kejap ya. Alright, so dalam batch operation lah, contoh je, operation you nak pasteurize the milk. Okay, ini batch operation maksudnya you masukkan dia dekat dalam satu tank. Okay, you fill in the milk. So pasteurization, you guys know, is actually a process where you want to get rid of the harmful bacteria. Betul tak? Bacteria atau pathogens. Ya.
Doktor.
Tangan apa doktor tulis?
Apa dia?
Doktor touch screen.
Saya touch screen. Si baik kejap no. Shot sendiri pula dah. Aduh, sorry lah guys.
Tak apa.
Lupa Mek. Kejap ya. Window. Share. Okay, saya share lagi sekali. Nampak dah Nampak. Korang ni sangat penyabar. Terima kasih korang. Alright. Ni batch operation lah. So you batch operation ni you ada one tank. This is only one tank One tank. Okay, you masukkan milk. So you tahu pasteurization, you nak apply heat. Okay, heat. Apa orang kata? High temperature, short time. HT, betul lah, short time. Okay. Batch. Okay, in batch operation ni, once you achieve apa orang kata tu, this particular process ni, you dah panas, everything is settled, then what happens is that you have to pour this out. You have to pour it out, send it to another unit of operation while it will be packaged. Boleh follow ke sekarang ni? Boleh follow so far?
Boleh.
Okay, so after this happens, korang kena basuh. You have to wash it. Wash it before you guys can actually start with another process. So nampak tak the tediousness of this particular batch operation? And sangat tak cost effective lah, sebab dalam industri food process engineering ni time is an essence. Okay, you have to remember. So you nak kena settle ni semua cepat-cepat. So remember first week yang saya bagi lecture ni, did you see the pasteurization machine yang pasteurization yang saya tunjuk tu? Tengok tak? Siapa dah tengok video?
Dah tengok.
Yang tu continuous. Yang tu continuous sebab dia berterusan. Dia bukan in batches. Okay, sebab yang tu kan dia ada plates bersusun. Okay. This is yang continuous process. Okay. Dia ada plates bersusun. So dia akan ada satu inlet where milk goes in. And then ada inlet, water goes in. Water ni dia kira milk akan lalu dekat satu section. Macam tu lah lebih kurang. Okay. Tapi water ni dia akan masuk dekat dalam section yang tak, it doesn't mix with the milk. And this water it starts with hot water. Hot water ni dia akan panaskan plates ni. It will heat the plates. So these plates will heat the milk. Korang faham ke dia punya konsep tu?
Faham.
Tak faham? Faham kan? So meaning that pasteurization ni first you kena heat the milk, lepas tu you kena cool it down. You have to cool it down, baru package. Baru you package benda tu kan. Okay. So this water ni, kira this section ni, dia akan heat the plates. Lepas tu ada satu section ni, dia akan isi dengan cold water. So it will actually cool the milk. Tapi this particular system ni continuous sebab milk akan berterusan lalu, and kerja orang kat hujung ni is just collect. And only from time to time akan dia berhenti this particular process untuk membersihkan plates tu. So dia boleh kumpul banyak milk all at the same time as compared to this batch operation yang korang hanya guna satu periuk, basuh, buat balik. So people in the industry usually they prefer the continuous one. So the batch process ni is quite tedious and very costly as compared to the continuous punya process. Alright, so materials and energy balances is very important in the food industry. Okay, material balances are fundamental to the control processing, like I told you before. Okay, so usually let's say lah kan, kalau you guys have like a plant, okay, a factory plant. Okay, you masukkan for example dairy milk tu kosong lah. It's only susu, sugar, a little bit of salt and also chocolate, cocoa. So let's say you masuk apa tu orang kata ni, let's say you masuk 3 kg of cocoa. Tapi your product comes to less than 1.5 kg. Macam immediately you have an idea, alamak, why does the production reduces? So where did another 1.5 kilogram of cocoa went to? So you kena pergi dekat plant tu, you have to find out where did the cocoa go, cocoa to build up dekat which of unit operation, which pipe, okay, which tank. So you have to, that's why it's very important for you to do this balance. Sebab bila benda tu tak balance, immediately you will know that something is wrong with the factory plant or your unit of operation. Okay, contohlah juga kalau accounting tu you have to make sure balance lah. Kalau tak balance tu maksudnya dia ada korup lah kat mana-mana, ada orang seleweng duit ke. It's similar to this kind of concept as well, okay. So material balances are fundamental to the control of processing, okay. Fundamental lah sebab you know what goes in, you should know apa yang masuk tu keluar balik, okay. And also control the yields of the product. Kalau boleh, like I told you before, 100% of the raw material goes in. Kalau boleh, you guys nak 100% of raw material coming out. Okay, so you nak control the yield. Okay, so kalau nak control the yield tu, you want to maximize the yield, but at the same time, you want it to be cost effective. So engineers ni memang tugas dia itu. Okay, kalau you nak jadi cost effective tu, you have to create a factory plant that uses uses macam less electric, needs less heat, less energy, tapi dia punya yield almost 100%. Macam tu. When any changes occur in the process, the material balances need to be determined again. Like I said tadi, kalau the changes tu, kalau you have, you masuk 3 kilos of cocoa, tapi yang keluar tu less than 1.5 or maybe 1.5. So you ada changes lah. Usually kalau you bawa masuk 3 kilos of cocoa, 3 kilos of cocoa should comes out. But then again, you don't see. There are changes in your process, there are changes in your end product. Okay, so that's when you need to determine again. When you determine again tu, like I told you before, you need to find mana dia pergi. As a waste, as the build up dekat dalam any of the dinding pipe. Benda macam tu, okay? Alright, energy balances are used in examination of various stages of process, okay, over the whole process, even extending over the total food production system from farm to the consumer plates, okay. Maybe you guys were asked, macam curious lah, if you want to draw this particular plant of material, apa orang kata, you nak the plans of this particular material balance ni, where should I start? Like I told you before, kalau you nak start, depends on the company. Kadang-kadang company tu memang dia hanya ambil raw material daripada tempat lain. Okay, like let's say dairy milk. Contoh, let's say dairy milk tu dia memang ambil apa orang kata cocoa in terms of dah powdered form. So that powdered form tu maksudnya you start you punya material balance tu daripada raw material yang tu lah. Raw material cocoa yang korang ambil daripada supplier. Okay. So this is your starting where you want to do the material balance. Contoh Sime Darby. Dia produce dia punya own oil, which means that dia ada ladang dia sendiri. So dia memang dia antara pengusaha ladang tu, dia yang proses that raw material, dia ambil that raw material untuk proses. So meaning that this raw material ni untuk diorang ni memang start daripada farm sampailah consumer's plate. So you can see, you can imagine. So it depends on your company. Kalau your company tanam pokok koko tu sendiri, so you have to start your material balance even daripada farm. Okay, even daripada, contoh lagi satu nak buat wagyu beef. You nak buat wagyu beef tu, you dah kena kira tu, you punya ladang ada tak, apa orang kata tu, cukup tak the grass. Because wagyu beef ni, the grass that are being fed is special type of grass yang ditumbuhkan dekat tempat yang being planted dekat tempat yang khas. Can you imagine kalau orang dalam industri wagyu beef tu, the raw material dia buat tu memang kena daripada ladang rumput. So faham tak? Okay. So it depends on you lah. It depends. Kalau in the future lah, amin, ada siapa-siapa nak buka kilang, dah kaya-kaya semua kan. You guys venture into this food and beverages punya industry. So you will understand. Macam bila you nak start to draw you punya balance ni. Okay, kalau you memang pengusaha daripada ladang, so you have to start from there. Tapi kalau you ambil raw material daripada supplier, you start from the supplier. Okay. Alright, food industry always examine means reduce energy consumption in processing to order cut cost of energy. Like I told you before tadilah, okay. Kalau engineer ni dia kena pening kepala sikit. Pening kepala in a sense that if you have a client, you upah the engineer and the client request this factory plant, saya nak buat sekian, you have to actually design it to be cost effective. Kalau cost effective memang usually memang kena reduce the energy consumption tu. Okay, meaning that kalau you use macam industry food ni, ada benda nak kena masak which actually involves heat. Ada benda yang memang kena macam masak macam dalam pressure cooker. Those requires a very huge amount of energy. So, and apa tu orang kata engineer memang kena find a way lah to kind of like apa orang kata ni, find a way to kind of like jadi cost effective. Contoh, kalau you guys nak apa tu orang kata, canned food lah. Canned food ni contohnya kalau traditionally small scale company ni dia orang macam nak buat pack of kari ayam lah. Kari ayam ke kari daging lah. So kalau yang apa tu orang kata factory biasa ni dia akan guna cara masak yang biasa lah. Slow cook, sebab korang tahu lah nak buat kari tu you want to tenderize the meat, you need a very long time untuk cook. So tu energy very high. So nanti engineer akan nak try to improve, dia bagi tahu lah, okay, this particular unit of operation instead of guna traditional cooking method, jom kita guna pressure cooker. Pressure cooker even though energy dia tinggi tapi dia masak tu cepat. Those kind of things lah. Even kalau macam mak-mak kita pun daripada periuk biasa, periuk noksa, primoda, macam tu lah. Dia macam upgrade. Okay? Alright, experience in working with individual unit operations will develop the ability to extend the methods to a more complicated situation. Tapi memang kalau macam like I said, small SMEs, dia punya unit of operation usually very small lah. Kalau macam nak buat sos, kicap-kicap, budu-budu, tu very small. Tapi once you guys dah jadi macam big guns macam Heinz, macam Life Sauce tu, diorang punya sistem tu lagi complicated sebab how do you say, diorang proses diorang tu macam menghasilkan up to millions of bottles a day tau. So different tau dengan small SMEs ni. So kat situ memang kalau usually orang-orang big company tu they are willing to invest more on the system atau teknologi supaya benda tu boleh can be like more cost effective. Okay. Alright, the advancement of computer science has made very complex mass and energy balances to be set up and manipulated quite readily. Hence, use every process management to maximize the product yields and minimize cost. If you remember that I told you last week, masa zaman saya dulu was like berapa 14 years ago. Kalau dulu tu macam 14 tahun lalu, masa zaman saya undergrad dulu, I went to yang CSR tu. Like I told you before, you guys tak perlu calculate benda ni one by one sebab benda tu the probe semua dah ada dekat each unit operation. Benda tu all connected to the control room yang memang ada advanced computer ni. Okay, but ada artificial intelligence lah, orang kata, that is been put into this particular system supaya kita tak perlu calculate. Benda tu yang akan perlu calculate kan. Alright, basic principles dah diulang banyak-banyak kali. A unit of operation can be represented diagrammatically as a box. Ni lah, okay. The mass of materials and energy going into the box must balance with the mass and energy coming out. Always remember it has to be balanced. Contoh here. This is the simplest contoh. A process of running at steady state involves 100 kilogram per minute stream with a mixture of water and sodium hydroxide. Okay, that's water, that is sodium hydroxide. So this plus this equals to 100, betul tak? So the mass flow of the outlet is 40, meaning kat sini automatically kena class 60. Okay, tapi if you were to kind of like zoom in pula, kat sini dah keluar, dah ada nilai untuk ni lah. Yang kat bawah tu dah ada nilai untuk H2O. Saya pula tak nampak ni. Hide. Okay. Alright, so nanti you guys can actually do the balance. Tak apa, saya pun dah tak ingat dah. Ada jawapan lah kat dalam slide tu kan. Betul tak? But at least you know that benda ni balance lah, okay? What go here macam sini, this should be 60. Tapi like I told you before, component per component kena buat balance. So you have to make sure benda tu also balance. Alright, so mass of energy balance. So like I told you before, basic principles akan ada raw material balance, which is the mass balance. Any energy balance lah. Like I said, dia akan start daripada electrical, chemical, heat, all this work. Ni semua energy. So the stored material, stored energy, products out, waste. Like I told you before tadi, ideally 100% goes in, 100% comes out, but that's not the case. Kita mungkin akan ada waste. Kalau other than waste pun, kita against time, kita akan ada build up dekat lining of the pipes ni. Okay, sebab kalau you guys you have to know, you want to transfer from one unit of operation to one unit of operation, memang akan guna piping system. Okay, contoh yang build up ni, especially yang anak teruna pun kena masuk lah. Kena masuk jugalah kitchen. Kan you guys when you buy new pans, okay, korang beli apa orang kata periuk baru, you notice dekat apa orang kata ni, dekat dia punya bahagian bawah tu licin kan, berkilat. But as time goes by, ada carbon build up kat bawah tu. Betul tak? So awal-awal dulu, apa tu?
Dia jawab betul.
Dia cakap
kan?
betul.
Betul tak? Masa awal-awal beli tu seronoknya, nak goreng ayam pun laju je, minyak pun cepat je panas, macam tu kan. Lepas tu as time goes by tu, bawah tu pula, ya Allah, dah jadi build up of this, apa orang kata, macam layer of carbon tu yang hitam tu. Lepas tu it takes a few while for you to actually panaskan minyak, lepas tu nak goreng nugget pun dah jadi tak best, macam tu lah. Those are contoh-contoh build up that also happens dekat this particular, apa orang kata, system lah, piping system ni. Benda-benda macam tu. So in order for you to kind of like mengembalikan the efficiency, you have to stop. Okay, kalau dia stop tu memang sakit lah, sebab bila dia stop, production stop, production reduces, memang akan melibatkan kerugian. It will cause losses. So bila stop, diorang kena bersihkan, sebab tu dia ada maintenance. Benda-benda macam tu. Kalau boleh, those are the things yang diorang nak try to reduce. The build up, berhenti untuk basuh, sterilization, semua tu lah. So if they want to design tu, you have to make sure benda tu sterilized, hygienic, cost effective, where dia tak ada build up selalu sangat. Alright, so bila ada build up macam tu, like I told you before, yang macam contoh pan tu, it takes more time untuk you, apa orang kata, it takes more time for you to heat and you want to cook the chicken, you will actually incur more energy. Kalau you have more energy, maksudnya dah tak cost effective lah, because you need more energy to kind of like proses tu dah tak efficient dah. Right, tu contoh paling simple lah, you guys can imagine, okay. Alright, so this is just a translation of this, okay. The law of conservation mass leads to what is called the mass or material balance. Mass in, mass stored, okay. Raw material product could be in the form of waste, could be in stored materials. Stored materials ni saya tak ingat lah contoh. Usually kalau stored materials, waste, stored materials tu saya rasa more like build ups lah, tak silap saya. The build up in the piping tu. So diorang kena ni lah. Even benda tu bila diorang collect pun diorang kena analyse, because they need to know how much are the waste, how much are the stored materials. Okay, so they can actually solve for this kind of problem to reduce any build ups, to reduce any waste. Kalau boleh, this is benda yang diorang tak nak, unwanted. Okay, unwanted. Okay, so nanti adalah total raw materials, total products, total waste products, total stored materials ni. Tapi kalau you were to kind of like tambah semua ni, you find the sum ni should be equals to the total of raw material that goes in. Right? Okay, if there is no chemical changes occurring in the plant, the law of conservation of mass will also apply to each component. Thus, for component A, okay, mass A stored in plant. Okay, example, a plant that's producing sugar, the total quantity sugar into the plant forms sugar cane is not equal to the purified sugar in the stream, then something need to be figured out. Maksudnya, okay, ni macam quite wordy. Let's give you an example. Apa ni, kalau sugar lah, contoh sugar ni, macam mana nak cakap? Okay, sugar ni, so usually kalau you kind of like extract the sugar, okay, sugar dia ada refined and unrefined kan, betul tak? Samalah dengan beras kan. Okay, I'm not sure kalau it goes through any chemical changes. Kejap let me think. So the quantity of sugar going in the plant form sugarcane is not equal by the total purified sugar in the waste stream. There's nothing to be figured out. Tak apa, mungkin nanti next week saya fikirkan contoh yang lebih jelas. Yang ni very wordy. Nanti saya cari contoh yang lebih apa kata ni? Kalau in terms of chemical changes pun, like Contoh kalau macam you guys start dairy milk, lepas tu nanti by the end of the day akan ada a bit of chemical changes. Dia akan jadi butter dengan margarine. Yang tu macam ada chemical changes kan in terms of diorang punya fat. Yang tu pun you guys have to figure it out. Contoh. So it starts with milk. Okay. And then daripada milk ni, you akan jadikan dia butter. And you akan jadi dia margarine. And margarine ni, dia punya chemical composition ni berbeza. So you have to do balance for both. Okay. Usually tak silap saya bukan macam ni sebenarnya. Milk, butter, daripada butter tu dia akan jadikan margarine. Dia macam tu. The process. This is a modified version of the butter by reducing fat content. Sebab tu kalau orang buat kek, orang yang konon-konon terror sangat buat kek tu yang premium tu, diorang tak akan guna margarine sebab margarine dia reduce the amount of fat. Kalau nak sedap diorang akan guna butter. Macam tu lah. So this process ni dia akan ada chemical changes because the nature of the fat changes tu. Yang tu you kena buat chemical balance lah. Alright, in case you do this particular balance, the fat that goes in daripada milk tu tak muncul kat sini, kena pergi check dekat waste atau build up. Okay, stuff like that. Okay, so material balance should be ni lah, raw materials, start daripada products. This is what you want or desired. Okay, waste product, stored products and losses. Losses ni usually problem juga. Kalau tiba-tiba hilang tanpa kesan, you have to find it. Okay, as I identify material. Okay, the energy is also conserved in food processing operations. Okay, the energy coming into a unit of operation can be balanced with energy coming out of the energy stored. Okay, kejap sebelum kita masuk energy ni, tapi losses ni memang diorang akan pening kepala lah because they really have to find mana dia pergi. Usually rare cases lah, tapi it happens. Alright, okay, so now is energy. Okay, sama juga dengan tadi, very detailed. Okay, so ni untuk total energy, entering, energy that leaves the product, energy waste materials, energy loss surrounding, also total energy stored. Similar je. Okay, tak apa, ni nanti kita akan look bit by bit. Okay, conservation of energy from one another. So I hope you still remember lah. Okay, so this is the form of energy that you will see in this particular course. Okay, and usually this particular energy ni is actually interconnected to one another lah. Okay, contoh yang ni I think pretty much you guys can have a read nanti bila dah habis kelas. Okay, so just to kind of like refresh a bit some of your memories is that you guys will see a lot of equations dekat dalam this particular course involves in potential energy, converting into kinetic energy, and also elastic potential energy, kinetic energy. Benda macam ni lah, you guys will see here, these two. Yang ni elastic tu bergantung pada the properties of your ni lah. Nanti you will see a lot of this masa kita study fluid flow nanti. Yang ni also important sebab aside dan fluid flow ni, Sebab you know the properties of food ni ada macam-macam jenis. Sometimes in powdered form, sometimes in liquid form pun. Dia bukan liquid yang cair. Sometimes it's very, what they call this, sometimes the liquid is very thick. Kalau macam jam ke, korang nak buat syrup ke, yang those maple syrup yang korang makan for your pancakes tu, in order for you to transfer into another unit operation tu, you will actually need macam turbine atau pump. Tu involve kinetic energy lah. You kena supply electrical energy untuk change it to kinetic energy and then to mechanical energy. So you kena pump benda tu. Dia bukan gerak sendiri, dia perlukan bantuan energy lah. So benda tu pun kena, you have to make sure you have to kind of like do the balance based on the turbines, rotor, pump, benda macam tu lah. Okay, cooling fan pun a types of energy, benda macam tu. So the first step is to look at the three basic categories: materials in, out, and materials stored. Okay, the materials in each category have to be considered whether they are to be treated as a whole or a gross mass balance, or various constituents should be treated separately, and if so, what constituents. So like I told you before, this is again totally up to you. Tapi sebenarnya apa orang kata, it depends on the nature of your product lah. Alright, so kalau macam contoh macam dairy milk tu, immediately dia memang cocoa, sugar, maybe a bit of water. Lepas tu you akan dapat ni lah, you akan dapat what do you call this, chocolate. Okay, imagine kalau korang ada KitKat. Dalam KitKat ada apa kelas?
Chocolate.
Lagi?
Biscuit.
Kalau biscuit tu maksudnya korang akan ada satu unit operation untuk buat coklat. Gitu. Lepas tu you guys kena ada satu unit operation untuk buat wafer tu. Lepas tu nanti korang kena ada satu unit operation untuk assemble. Lepas tu baru ada untuk packaging. Okay? Like I said lah, kalau the nature of your dairy contoh dairy chocolate tu, kalau korang nak buat in one gross material balance pun tak apa, sebab tak banyak tak banyak raw material is being put into this particular product to make the final product. Tapi kalau macam KitKat contohnya, tengok ada coklat, ada wafer, and wafer ni pula nak kena mix lagi, you have to bake it in an oven lagi, so you nak kena assemble lagi. So yang ni mungkin akan perlukan a very unit of operation yang berbeza, yang kena pecah. You have to break it down. So like treated separately, and what constituent. Macam tadi tu, macam coklat, wafer. Lepas tu baru akan ada assembly line, assembly punya unit operation, right? Alright, like here for instance, takes dry solid as opposed to total material, separating the two group of constituents. Tadilah liquid and non-liquid. Coklat tu selalunya dalam bentuk liquid, wafer tu dalam bentuk solid. See, more complex categorization can separate out the chemical types such as minerals, chemical elements such as carbon. So benda ni you have to take into consideration lah. Kejap Have you guys ever done any proximate punya lab before tak? Proximate, pernah tak? Macam mana nak check moisture, ash content, pernah buat ke sama tu?
Pernah.
Okay, so this benda ni sama jugalah. Kalau usually once you ada final product, so you want to know the quality of your product. Sebab kalau ikut teori, kalau let's say you produce dairy chocolate tu. Okay, kalau you produce that dairy chocolate, you dah kena sedia maklum final product tu hanya ada sekian-sekian moisture je kat dalam tu. So basically all the products yang korang dah buat tu will be sent to quality assurance punya lab untuk testing benda tu. Barulah once benda tu dah for each batch yang dia proses tu, each batch tu semua akan dihantar ke quality assurance, and quality assurance akan buat test tu to make sure semua constituent yang ada dekat dalam tu matches the label, the final label yang korang tengok dekat belakang packaging tu. Okay, so tu contoh-contoh dia lah. Why you need to actually do this particular balance, quality assurance, to know the quality of your product as well. Alright. Alright, the choice and detail depends on the reason of making a balance and on the information that is required. Okay, again, it all depends on your ni lah, on your product. Okay, like major factory in industry, the value of materials, especially kalau expensive raw materials, are more likely to be considered than cheaper ones, and products rather than byproducts. Contoh, kalau macam coklat tak sangat. Kalau pembuatan apa benda expensive, bagi contoh. Apa makanan yang expensive untuk korang?
Kinder Bueno.
Yes, ice cream tu very good contoh. Korang tahu tak dekat dalam industri pembuatan ice cream, there's actually four types of ice cream. Ice cream Ini memang apa orang kata by the book tau, memang ada dalam buku teks. 4 jenis ice cream. 1 premium, 1 eco bawah sekali. Eco, semi eco. Lepas tu ni semi premium. Okay, contoh siapa yang bagi apa ice cream tu bagus. So benda ni tak silap saya lah, nanti I will check back. Tapi memang ada 4 types of ice cream. This is what my supervisor told me dulu. Sebab I attended his class. So bila you nak buat eco ni, eco ice cream ni, okay, dia punya level of fat very low. And the texture yang dapat ice cream tu dia ganti dengan gelling agent. Macam carrageenan, gelatin. Sebab tu kalau korang perasan kan, kalau eco punya ice cream tu tak sampai 5 minit kat luar dah cayak. Contoh McD. Bukan nak kutuk McD lah kan. Korang beli McD tu sekejap je dah menjejir-jejir kat tangan kan. Yang tu eco atau semi eco. So dalam pembuatan ice cream tu, apa orang kata ni, bukanlah you don't put the heart to it, it's just that benda tu diorang macam tak kisah sangat. Tapi if you do premium ice cream ni, contoh premium ice cream ni, siapa tahu premium ice cream sebab apa?
Baskin Robbins. Magnum.
Baskin Robbins tu semi premium dia bukan premium.
Jauh-jauh.
Häagen-Dazs.
Yes, Häagen-Dazs tu premium.
Ben
So, even yang kalau perasan Häagen-Dazs tu pun, kalau korang perasan dia guna apa orang kata ni? What they call this? Vanilla tu. Bukan vanilla perasa tau, dia guna vanilla beans. Kalau ice cream macam ni, material balance dia memang very specific sebab dia very expensive. So kalau boleh 100% goes in, at least more than 95% should come out. Kalau boleh diorang akan reduce losses untuk ice cream macam premium ni. Okay. So different lah. Even the fat, the content of fat, texture yang ada dekat dalam premium ice cream ni, especially kalau korang pergi dekat European countries yang jual gelato tu, beli ice cream dia dah berapa minit dekat tangan tu tak cair-cair. It's because of the percentage of fat yang ada dekat dalam ice cream tu very high. Sama juga macam Häagen-Dazs. Nanti balik kejap lagi pergi shopping, beli 1 cup Häagen-Dazs tu yang RM30 tu dengan yang walls yang RM4.5 tu, RM2.5, bandingkan. If you have the time lah and also the money lah. So dalam pembuatan tu, kalau you buat premium ice cream ni, dia tak akan main-main lah. Sebab contoh-contoh barang-barang yang diguna tu memang extremely expensive. Okay. Alright, so after decided which constituent need consideration, the basis of calculation has to be determined lah. Like ni nanti boleh baca later lah. Okay, some mass of raw material entry process in batch system. Okay, mass per hour, continuous. Okay, so it depends lah whether benda tu dalam batch system atau continuous process. Okay, you decide on that. Okay, like I told you before, kalau boleh orang nak continuous. Orang akan favor more on continuous process. Okay. Alright, sometimes it is unimportant what basis is chosen. Okay, in such areas, convenient quantity such as total raw material in one batch or pass in per hour, continuous process. Sometimes it is important basis chosen. Tak apa ni ignore. Tak ada apa sangat. After select the basis, then the units can be chosen such as mass or concentration or molar. Okay, benda macam ni. Korang belajar kan dekat dalam lab apa ni? If you were to do lab, korang belajar kan mass, concentration, molar. Belajar tak? Cara-cara tu tak apa. Ni nanti kejap lagi kita tengok yang mass, concentration, molar. Tapi usually untuk case kita lah food process engineering ni, mostly kita akan apa orang kata, we will use mass lah. Mass. Kita akan guna weight. Tapi molar, concentration or molar ni, sebab dekat dalam food process engineering ni, example lah dalam pembuatan suplemen. Kalau if you make supplements, you guys don't play around like chocolate dah. Korang memang guna apa orang kata ni, chemical compound to be compacted in the tablet. Okay, tu nanti bila dah start you punya apa orang kata, you punya produk tu dah scale down jadi that small, mungkin you guys will start using molar and concentration. Okay, this is an example of balance lah, the simplest balance. Okay, consistent balance of milk. Okay, skim milk is prepared by the removal of some fat from the whole milk. Okay, and then this skim milk is found to contain ni after lah, this is all the percentage after product. Okay, percentage of after product. Okay, so after dia buat skim milk ni, the skim milk is found to contain 90.5% of water, 3.5 of protein, 5.1 of carbs, 0. fat and ash. Okay, if the original milk contains 4.5%, calculate the composition of the original milk. Okay, to remove the skim milk and there's no losses in the processing lah. Dia dah beritahu no losses. So maksudnya korang 100% goes in, 100% goes out. Okay, ni contoh je lah. But don't worry, this is just to show you the material balance. Okay, ni contoh. Dah tak boleh nak imagine sangat in terms of words. Dia change in terms of ni buat diagram. So this is the whole milk, original milk. This is the skim milk. Skim milk ni semua dia dah bagi the composition. So you guys just want to know the original composition. So this is the calculation lah. Nanti boleh tengok lah later, okay? But these are the balance. But don't worry lah, I won't ask you any calculations lah.
Doktor, nak tanya. Kenapa defisit 100 kilo?
Apa tu? Dia macam tu. Dia for this particular ni bukan common practice. It's just that dia basis 100 kilo tu for this particular problem sahaja. Dia nak terus dikira macam dia assume 100 kilo ni equals to 100%.
Oh, okay.
Faham tak? So dia macam terus assume je lah. Sebab dia bagi dalam bentuk percentage. Macam ni kan? So dia akan assume okay ni 90.5 kilo, 3.5 kilo. Tapi usually sebab ni contoh. Tapi usually kalau real nanti calculation, contoh-contoh calculation yang dekat website saya bagi link tu, dia lain sikit lah. Dia akan terus bagi in grams, specifically berapa gram, berapa. Dan ni is just to assume. Sebab dia bagi dalam form of percentage. So dia terus assume original percentage adalah 100 kilogram. Macam tu lah. Alright. So maksud ni, kalau macam ni maksudnya 4.5 kilogram, 86.5 kilogram. Tapi just make sure you guys understand lah macam mana nak buat balance ni. Tapi most likely saya tak akan tanya lah. Okay, sebab kalau engineering student mungkin akan they need to do this calculation. But to me, you just need to understand the concept. Okay, why do you need to do this material balance? Okay, also saya takkan tekankan ni lah sebab I think you guys have done this before. Ni semua dah ada contoh. You can have a go at it later. Okay, sebab macam concentration ni macam kejap let's see. Korang pernah tengok kan yang weight over weight, weight over volume, mole fraction, ni semua dalam chemistry punya kelas ni. Korang punya kelas nak calculate ni lab. Kan, pernah tengok kan? Tak apalah kita go through. Okay, the weight concentration is the weight of the solute divided by the total weight of the solution. Okay, Untuh teruslah. Okay, a solution of a common salt in water is prepared by adding 20 kilograms of salt to 100 kilograms of water. Okay, to make liquid density, dia bagi density lah. Okay, so in terms of apa tu, kalau tu weight over volume, molar concentration ni ada one of these. In order for you to calculate ni, dia akan guna the density. So that's why dia bagi this particular apa ni, kata ni density of water. So dia kata calculate the concentration of salt in the solution, weight over weight fraction, weight over volume, mole fraction and molar concentration. So kat sini kalau weight over weight fraction maksudnya 20 kilograms of salt. Okay, 100 tambah ni. Okay, the weight. So dia nak tahu weight fraction of salt dekat dalam air tu. Dalam air tu kan. So 20 kilograms of air tambah dengan 100 kilogram of air tambah dengan 20 kilogram of salt. Tu cara you calculate apa tu, apa orang kata ni, weight fraction, weight over weight. So 20 over 100, 20. That's how you get this percentage. Alright, weight of fraction. Okay, tak apa, nanti you guys can look at this later. Okay, kalau weight over volume fraction, bila dia dah start guna W over V ni, you guys will know immediately dia memang akan the density ni. Okay, so meaning that kadang-kadang dia tak akan bagi when you do your lab lah, nanti masa FYP you masuk lab tu, you always have to remember the first thing that you need to do is to find out the units dekat dalam you punya journal tu, sama ada orang tu guna weight over volume, sama ada orang tu guna weight over weight. Kalau macam supervisor saya dulu masa PhD, dia lagi prefer weight over weight. So every single thing that I do dekat dalam lab memang guna units yang macam ni lah, basis and units of weight over weight. So bila dah start weight over volume ni, you guys know that the density is needed in this particular equation. Similar weight over fraction, tapi dia akan darabkan dengan the density of the salt. Okay, so once you get the density of the salt ni usually memang kalau you nak tahu dia punya fraction tu memang usually dia akan dalam 1 liter over 1 liter. Okay, nanti ni korang boleh recap balik tau. Okay, sebab tu 220.5 over 1 liter. Ni 1000 dm 1000 cube ni sama dengan 1 liter. That's when you get ni. Tapi you perasan tak dia berbeza? I don't know, but according to my supervisor, dia lagi suka weight over weight fraction sebab dia kata weight over weight fraction ni lagi tepat as compared to this one. Dia macam nampak lebih kurang sama lah, tapi jauh beza juga sebenarnya. Like this one 22, this one 16.7. But it's totally up to you and it's totally up to your field. Nanti buat FYP pun tengoklah korang punya journal guna what type of fraction. Okay, what type of basis and units. Okay. Alright, kalau mole fraction, memang korang automatically akan tahulah kena ada molecular weight is involved. Betul tak? Guys, tak apa, nanti korang tengok balik lah yang ni
Yes.
Alright. So concentration, okay, with gases, gases ni lain sikit lah. Ini semua in terms of mass and also in terms of liquid sebab volume ada liquid kan. Okay, with gases, concentrations are primarily measured in weight concentration per unit volume of partial pressure. This can be related through the gas law using the gas law in terms of PV equals to nRT. So P is the pressure, V is the volume. Kalau in terms of your nature of your work atau nature of your factory plant tu menggunakan gas, okay, this is what you need to do. This is dia punya basis unit untuk calculate basis unit for dia punya concentration. Okay. I mean like very unlikely for you to have this lah dekat dalam kita punya apa orang kata bidang ni. Tapi imagine lah contoh. Kalau gases ni yang macam aerosol tu, korang nak buat Ritsack tu kan, korang nak buat Ritsack tu, dia ada gases involved kan, dia kena compress in order for you to get that property of aerosol tu. Mungkin diorang perlu, they need to actually use this basis unit concentration lah sebab dia ada gases. Alright, I'm not going to go through this later, you guys can ni lah. Okay, tadi in batches kalau macam contoh tadi kita calculate ni, ni in batches lah. Sekali keluar, sekali masuk, sekali masuk, sekali keluar. Okay, what happens kalau benda tu in continuous punya batch? Kalau continuous punya batch ni, okay, in continuous process, time also enters into consideration. So this is when you start to see, sebab dia bermain dengan time. Okay, the things that you actually need to, the term you will start to see is rate. Okay, rate of flow. Okay. Okay, tak apa, nanti kita tengok. Okay, time also enters into consideration and the balances are related to unit time. So memang dia berkait dengan rate of flow ni. Okay, so hence considering continuous centrifuge, contoh considering a continuous centrifuge separating whole milk into skim milk and cream. If the material holds up in the centrifuge, it's constant in both in mass and composition. Okay, so then the quantities of the components entering and leaving in different stream in unit times are constants and mass balance can be written on the basis. Maksudnya sebab dia tadi saya bagi contoh yang milk tadi tu, milk is constantly being fed dekat this particular plates. Kan ada plates tadi kan? Plates. Lepas tu ada inlet masuk milk, ada inlet masuk water. Okay, so yang ni sebab dia continuous. Okay, usually apa orang kata ni, usually for contoh what comes out from this particular machine ni, kira macam dia kena produce 3 liters of milk per minute. Per minute. Nampak tak? So in case, so maksudnya milk goes in ni should be fed, maksudnya 3 ml of milk ni kena masuk 3 liter of milk every minute for you to get 3 liter of milk product every minute. Macam tu. So dia dah bermain dengan apa orang kata ni, dengan masa lah. 3 minit dia masuk, dalam 3 minit tu juga dia akan dapat 3 liter masuk, 3 liter tu keluar dalam masa 3 minit tu. So it's being fed by minutes. Okay, kalau ada kekurangan dalam hasil ni, meaning something is wrong with this particular machine. Okay, alright, so maksudnya dia kena constant lah. I mean like all this while dia buat susu, dia pasteurize the susu ni 3 liter per minute, kalau macam every hour, kalau tak minute pun, let's say supposedly if you fed 3 liter of apa orang kata ni, milk sejam, there should be like 3 liter of milk coming out sejam tu juga. Kalau you guys get it lah, macam tu lah, dia kena balance. Alright, so example, if 35 kilograms of whole milk containing 4% is 4% fat is to be separated for a 6 hour, ni dia bagi hour. Okay, into skim milk with 0.5 fat and cream 45%. Okay, flow rate, tapi you notice dekat last kali dia memang ada per hour. Alright, so total mass yang dia bagi adalah 35,000. So you have to divide into 6 sebab dia bagi total of 6 hours. So this is the total mass that is being fed per hour. Okay. So and then this one times by 0.04 separated ni, you get this particular value lah. Tapi tak apalah, just to show you contoh continuous process, I'm not going to kind of like emphasize on this particular calculation lah. Alright, you guys can actually have a look at this later lah. Alright. Alright, the time unit has to be considered carefully lah in continuous process sebab dia continuous, dia bukan by batch. Kalau by batch, time is not considered as an essence lah. Tapi kalau continuous process tu sebab dia continuous kan, so meaning that like I told you before, kalau ada you fed this particular milk 3 liter per hour, you should get 3 liter per berapa liter per hour tu dia kena match. Dia macam kena constant lah, okay, of this particular raw material going in, raw material coming out at that certain time, macam every 6 hours ke, every 3 hours ke, depends on your process, okay. Alright, the time unit has to be considered carefully in continuous process. Okay, such process operate continuously, only part of the total factory time. Okay, usually there are 3 periods lah: start up, continuous, and then close down. Selalunya close down ni memang untuk maintenance lah. Maintenance. Okay. So during maintenance ni dia akan ada ni lah, material balance will be studied. Sebab this akan determine the efficiency of your plant atau unit of operation. Okay, the time interval over which any measurements are taken must be long enough to allow for any slight periodic or chance of variation. Alright. So blending, nanti later you will learn in detail lah pasal blending, drying, semua tu dengan Dr. Tan. Dengan saya cuma sampai heat, fluid flow ke heat transfer. Alright, okay, tak apa, nanti this one you will learn later lah. Okay, complicated examples, find an optimum of best achievable position need quite elaborated calculation methods such as linear programming, but simple example can be solved by straightforward mass balance. Tapi again, like I told you before, kalau small factory or unit operations yang the amount of raw material is manageable, mungkin you boleh buat manually lah. Tapi kalau benda tu dah complicated, I told you before, dia akan ada letak probe dekat dia punya unit of operation. Dia ada probe, and this probe is usually connected to control room atau control tower. Okay. Alright, energy balance. Okay. Tadi semua material balance Contoh-contoh material balance. Alright, for energy balance, energy takes many forms such as heat, kinetic energy, chemical energy, okay, potential energy, but because of intro conversion, it is not always easy to isolate separate constituents. Maksudnya kalau energy balance ni dia a bit complicated sikit. Sebab it's very difficult for you to calculate energy balance. Tapi still you have to do it lah, okay. However, under some circumstances, certain aspect predominates, okay. In many heat balances, other forms of energy are insignificant. In some chemical situation, mechanical energy is significant. Again, this also depends on your factory plants, depends on your unit of operation, okay. What kind of energy that they actually use. Tapi if I'm not mistaken, most of these energy balances ni memang the probe yang diorang guna adalah untuk measure heat. Okay, sebab most of this kinetic energy tu memang akan, sebab dia berkait dengan pergerakan dan collision. So this collision tu yang akan memang produce heat. So something like that as well. So memang dia akan measure guna heat. Masak guna heat. Macam if you kind of like, macam like I told you, kalau ada motor, ada turbine, ada pump, kalau ada collision tu dia akan produce heat. So that's how they do the energy balances. Alright, practical applications of energy balances tends to focus on particular dominant aspect. Contoh, like I said, heat balance. Memang, this is the, main energy involved. Energy involved, and at the same time, this is also benda yang boleh, that can be measured or detected. Okay. For instance, okay, can be useful lah. Memang akan usually heat balance. Sebab tu nanti in your course alone for this pun memang you guys will see a lot of heat transfer saja dua minggu punya lecture. Alright, so the importance or I might say the dominance of the heat balance, okay. Energy balance can be calculated on the basis of external energy used per kilogram of product, raw materials processed or some key components, okay. The energy consumed in food production includes direct energy or indirect energy, where direct energy macam contoh fuel, electricity, okay, like farm, transport, factories, in storage and selling. Again, like I told you before, this depends on your company, bukan company lah, your factory lah, factory plant. Like I told you before, kalau you guys ambil raw materials daripada if you take raw materials daripada supplier, so mungkin you just need to kind of like buat balance untuk transport. Yelah, transport kan guna engine, guna fuel, those you need to do balance. Okay, kalau you ada farm, tu you have to do another set of energy balance lah. Contoh yang saya boleh bagi tadi tu macam wagyu beef tu lah. Okay. Okay, indirect energy which is used to build the machines to make packaging to produce electricity and the oils and so on. So even packaging pun is very important. Alright, so again, food itself is a major energy source and energy balance can be determined for animal or human feeding. Food energy input can be balanced against output in heat and mechanical energy and chemical synthesis. Sebab food ni is also a type of science lah juga kan. So you know that macam apa orang kata ni, we learn that macam all this enthalpy, thermodynamic, enthalpy, apa tu yang apa lagi term-term yang heat, release heat, dia apa, release heat, dia simpan heat, apa? Do you remember the term, class?
Exothermic.
Yes, exothermic dengan endothermic. So the nature of the food itself also kind of like contribute to the, what do you call this, the balance, the energy lah. Provided kalau this particular production of energy atau heat is significant. Kalau benda kecil-kecil tu it's negligible lah. Tapi kalau benda yang besar-besar tu you have to consider lah. Usually contoh macam dalam oil and gas company lah. Oil and gas company tu banyak sangat guna combustion punya teknologi. Kalau combustion, you use a lot of heat. That is when you see the changes, exothermic, endothermic semua tu. Tapi in food, tak adalah. Unless kalau you see benda tu besar, then you will do the balance. Kalau you rasa macam the chemical changes tu kecil, probably most of the time negligible lah. Okay. Alright, the SI system, there's only one energy unit with joule. Ni nanti korang akan tengok later lah. Okay, however, kilocalories are still used by some nutritionists. Alright, most common important energy form is heat energy. Alright, and the conservation of this can be illustrated considering operations such as heating and drying. Yang ni nanti dengan Dr. Tan, dia akan ajar. Sebab dia akan ambil all parts yang sieving, drying, grinding, blending, tu part dia. Yes, enthalpy. Inilah good yang ada apa exo, endothermic semua tu, okay? Enthalpy balance can be written around the various items of equipment, process stages, okay? Around the whole plant, okay? Assume there's no appreciable heat converted into any other forms of energy. Ini senang cerita lah, kalau this heat, like I told you before, is traceable, atau dia punya changes tu significant, then you akan buat balance tu lah. Kalau rasa macam kecil sangat, you tak akan buat lah. Okay. Macam ni kan, heat of electricity. Excuse me, saya minum air kejap. Contoh heat lah. Heat from electricity, heat from fuel combustion, heat from mechanical sources, heat in raw materials. So, we'll do heat balance. Tapi ni memang predominantly the energy that you will ni lah. Okay, this is very predominant, satu. Secondly, usually from this balance also, you can find out if something is wrong with your plant, your factory plant tu. Okay, especially macam contoh lah kan, like I said dekat unit of operation tu, kalau ada banyak unit of operation, dia akan ada probe. The probe ni usually dia akan ada banyak types of probes lah, tapi one of the probes tu memang dia akan measure heat. Heat in terms of temperature lah. Kalau dia akan nampak temperature spike that is beyond normal, orang akan boleh tahu lah immediately something is actually wrong with this unit of operation. And usually kalau dia orang saw any irregularities atau anomalies dekat this particular heat ni, dia akan cepat-cepat entertain to that particular apa orang kata problem. Sebab this can actually cause a very huge accident. Okay, that's why you need to do the balance. Also for you to avoid any problems atau accidents, major accidents. That's why you need to know. Alright, working out energy balance is then just a matter of considering the various quantities of materials involved. Okay, specific heats and the changes in temperature, latent heat, okay, arising from phase changes. Tahu kan latent heat? Haba pendam. Right. Tahu kan? Do you remember? If you still remember, apa dah nak habis latent heat, kalau korang perasan tak dia punya, kalau water changing punya phase, pernah tengok tak? Dia punya graph. Perasan tak? Dia punya graph kan akan start macam ni, naik macam ni, naik macam ni, naik macam ni. Dia macam tangga. Because pernah tengok tak? So this is actually the temperature ke? Temperature ke energy? So I forgot lah energy. This is the phase punya change. Okay. So meaning that here, ni semua yang tempat yang stagnant ni, this is dia punya latent heat phase. Latent heat phase. Sebab dia akan perlu pendam that particular heat. Maksudnya latent tu dia akan ambil dan dia akan kumpul sampailah enough the molecule to actually move themselves from one another. Baru diorang boleh pecah daripada stage ice to water. Saya pun dah tak ingat dah, lebih kurang macam tu lah. And then to apa orang kata evaporation tu lah, through air, macam tu lah, pressure, water droplets ke. So this one tu memang the stages of haba pendam, latent heat. Okay, so that's what it means. Okay, latent heat is the heat required to change at constant temperature, a physical change from solid to liquid, liquid to gas, or solid to gas, sublimation. Sensible heat is a heat which when added or subtracted from the food changes the temperature, thus can be sensed. Okay, that is sensible heat, which is added bila perlu saja, when needed. Okay, tapi most of the time kita akan check for this latent heat rather than sensible heat. Alright, so the unit of latent heat is joule over kilogram. Okay, always remember kita akan guna standard units. Okay, and total latent heat is calculated by multiplying the mass of the material, change its phase by the latent heat. This is dia punya ni lah, the formula. The formula. Q is the energy released or absorbed in terms of kilojoule. That's the mass and also that's the latent heat. Okay, so usually sebenarnya every materials ni, kalau you check dekat dalam handbook, engineering punya handbook, dia dah ada predetermined lah. You just kena masukkan je nilai dia. Kan? Korang pernah nampak handbook kan? Chemistry. Pernah tengok tak handbook? Saya tunjuk contoh handbook of chemistry. Nampak tak? Ni contoh handbook. Can you see? Yes.
Nampak.
Handbook tau. Dia tebal gila tau. Dekat dalam ni semua ada value that you need to find. Dia ada listed banyak kalau maklumat yang korang nak cari. So contoh-contoh lah. Tu contoh. So tu ni lah, ni itu handbooks of physics and chemistry. Okay. Kalau engineering pun dia ada handbook dia sendirilah, tebal macam tu juga. Muka surat apa ni? 9,000 lebih. Alright, so meaning that this particular latent heat ni dah pre-calculated and usually memang akan ada dalam handbook, so you just need to actually find it in the handbook. Alright, so the unit of specific heat, which is again joule kilogram over Celsius, is sensible heat change is calculated by multiplying the mass by the specific heat and the change in temperature. Macam tadi, ml kan? Ini mass. That is apa sih? This is changes ni sensible heat. Sensible heat change. Alright, see. Alright, so the most common mechanical energy is the motor power, like I told you before. Okay, kalau you want to transfer one fluid to another fluid kan, dia macam it will need some sort of an assistant lah, because tak semua fluid ni nature dia macam water. Water you can actually push a bit, you can move it. But sometimes imagine if you want to make candies, you want to how do you say, even if you want to make chocolate tu, but you have to kind of like buat molten sugar dulu. Molten sugar ni is very, orang kata very thick. Okay, so in order for you to transfer from one pipe to another pipe, it will actually need some assistance. Perlukan motor energy lah. So you will see this electrical energy. Okay, contoh where, if you were wondering where the energy comes from, it comes from this lah. Okay, the most common mechanical energy is motor power, and it is usually derived in food factories lah for electrical energy. So it can produce steam engine and water power. So benda ni semua memang untuk transfer, apa orang kata, to transfer fluid sebenarnya. Nanti next class kita akan study pasal fluid flow. Okay, there are always losses from the motors due to heating, friction, windage. Okay, windage is actually created on an object by friction when there is relative movement between air and wind. Okay, when considering movement, fluid is pumped, jump fluids, I told you before. In pumping, solids handling, okay, mixer, nanti blending, sieving. Korang tahu kan sieving? Bila you nak asingkan based on dia punya, what do you call this? Berat dan size. So sieving ni dia akan ada this one machine tu yang macam tray. Kurang baking tak? Baking kan? Korang tahu yang benda yang ayak tepung tu?
Tahu.
So ayak tepung tu, dia ada benda yang sama juga. Dia akan ada mesin untuk goyang-goyangkan dia. Tapi yang sieving punya, dia punya apa orang kata, sieving size tu akan berbeza lah. So dia akan ada beberapa tingkat. Those kind of things to movement tu semua perlukan energy. Okay, the flow situation can be analysed by recognizing the conversion of total energy, where energy of motion or energy loss in friction. So friction, semua benda ni is actually form of energy. Tapi like I told you before, kalau energy, the friction, the heat yang dia produce, friction tu very small, then it is negligible lah. Tapi kalau that friction is very huge dan sekali dia gerak tu, dia produce a very huge form of heat, tu you kena have you kena buat balance lah. Okay. Alright, so chemical energy released in combustion can be calculated from heats of combustion of the fuels and the rates of consumption. Okay, eventually energy emerges in a form of heat and its quantity can be estimated by summing the various sources. Alright, summing tu, once you dah buat all this balance tu, nanti you just sum up everything. Okay, that's it. Thank you for your attention. Oh, sejam lebih juga. Okay. Yes, right guys, so that's it for today. Next week tengoklah kalau I'm not sure, I seem to have something. Kalau saya tak record, kalau kita ada live session pun, I will share the details dekat Google Classroom, and next week I will give macam